everybody. So homework, chapter 5, exponents and logarithms review. So this is a review for the unit test that you have on either Thursday or Friday. I'm going to go kind of quick through these problems to hopefully make this screencast short and sweet. Probably going to have 2 of them, but you know the deal. Pause, rewind, go back, whatever you need to do in order to get down the notes and see it as many times as you need it. So starting out with number 1, asking you to evaluate each expression without using a calculator. So we have 4 to the negative 2. This is A, by the way. 4 to the negative 2. Negative exponents tell us to do the reciprocal. So I have 1 over 4 squared, and 4 squared is 16. So this gives me 1 over 16 as my solution for A. Going over to B, I have negative 3 to the negative 1 power. So again, negative exponent tells me to do the reciprocal, so negative 3 to the first power. My exponent is now positive. Anything to the first power is just itself, so this is 1 over negative 3. And there's my answer for B. C says 1 over 5 to the negative third power. So this is going to, again, negative exponent tells me to flip my fractions. This is going to be 5 over 1 to the third. Now I have the quotient of a power, or power of a quotient property rather. My exponent goes to both numerator and denominator, so 5 to the third over 1 to the third. 5 to the third is 125. 1 to the third is 1, and 125 over 1 is just 125. And there is C. Coming on down to D, 49 to the 1/2 power, rational exponents. So 1/2 power is the same as the square root of 49. The square root of 49, we know, is simply 7. All right, so on to E. So, E says 64 to the negative 1/3 power. So that will be equal to, I'm going to change that to 1 over 64 to the positive 1/3 power. So get rid of the negative exponent and then change the rational exponent to 1 over the cube root of 64. Now the cube root of 64 means what number to the third power equals 64, or what number times itself 3 times is 64. And the answer that we fill in the blanks there is 4. 4 times 4 times 4 is 64. So the cube root of 64 is 1 over, well, the cube root of 64 is 4, and because it's written in the denominator, our solution is 1/4. F says 9/16 to the 3 over 2 power. So here we have plain positive exponent. The 3 over 2 can be given to both the 9 and the 16. So this is 9 to the 3 over 2 power and 16 to the 3 over 2 power. And then using rational exponents, this becomes the square root of 9 to the third power over the square root of 16 to the third power. So calculating this, the square root of 9 is 2 to the third power over the square root of 16 is 4 to the third power. So 2 to the third power is 8. 4 to the third power is 64, and I can even reduce 8 over 64, which could be 1 over 8 as my final solution. So I think I actually had that wrong on my review sheet. I had, yeah, okay, so 1 over 8 for F. On to G. -7 to the 0 power. Anything to the 0 power is 1. Because the negative is out front, The answer is -1. I hope that one's on the test, right? H, 3 times 2 squared. Remember to do order of operations, exponents first. 2 squared is 4, so this becomes 3 times 4, which is just 12. Oh. I, 0.6, -2 to the -1/2 power. Seems like this one you'd have to have a calculator for, but in reality, when you multiply your two exponents together here, you get -2 times -1/2 is a +1. So this is 0.6 to the first power, which is just 0.6. And there we are for number 1. Okay, moving on to number 2. Rewriting each in another form. So for A, so this is 2A, you have log of x plus log of y. Using our product property, this is the log of x times y. B says log z over y. So when we divide, we know we must have originally had subtraction, so this should be log of z minus the log of y. There's our answer for B. C, 7x, the 2.1 power, times 0.3 x to the 4.7 power. So using properties of exponents, I am first going to start out by multiplying my numbers. So 7 times 0.3 is 2.1. And then my x's are the same, x and x. When I multiply the same bases, I add my exponents. So this becomes x to the 2.1 plus 4.7 power, which in the end equals 2.1 times x to the 6.8 power. And there's the answer for C. Moving right along on to D, rewriting in another expression, log w to the k power. This is our power property, which is rewritten with the exponent in front of the log, so k times log w would be how that one would be rewritten. Moving on to E, the 5th root of x. Remember, if there's no exponent on the number or the variable, it's always a 1. So this becomes x to the 1/5 power. F, log base 5 of t. Here we have our change of base property. So our base is 5. We can't use 5. We have to have 10. So we change this to log of t divided by log 5. And there we have number 2. Okay, number 3. Switch up the color for number 3 with some blue. Number 3. Once a certain medicine is in the bloodstream, its half-life is 16 hours. So half-life equals 16 hours. How long to the nearest 0.1 hour will it be before an initial 45 centimeters cubed of the medicine has been reduced to 8 centimeters cubed? So here's what we have. We have 0 hours where they're given 45 grams or 45 centimeters of the medicine. We want to know at what time will there be 8 centimeters left. Since it has a half-life of 16 hours, then 16 hours there'll be half of the 45 left, which is the 22.5. So I'm going to use this information first to get an equation, and then I'll plug in what we're asked, what we're asked to find in order to actually get my solution. So point ratio form. So here's x, y, and x1. Well, here is 1, 1. Here's x, 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 and y. Doesn't matter, but the way I have it in my notes, I have it this way. So I have all the math worked out already. So here I would have 22.5 equals 45 times, I don't know what b is, to the 16 minus 0 power, dividing both sides by 45, so that I start to solve for b. I get 0.5 equals b to the 16th power, 16 minus 0 is 16, and then I raise this to the power of 1 over 16, same thing with the other side, 1 over 16, and b equals 0.9576. So I can use this equation now, y equals 45 times 0.9576, and 45 is the initial, so this is just x, so it would be x minus 0, but I don't really need to have the minus 0, so it could just be x, but I'll just put it in as a placeholder. So now I'm going to use what we just did there, use the equation that we just found, and try to figure out x when there's 8 grams left. So 8 is going to be my y. So I have 8 equals 45 times 0.9576 to the x power. Divide both sides by 45. 8 divided by 45 is 0.17 equals 0.9576 to the x power. Using my property of logs, I get that the log base 0.9576 of 0.17 equals x, so x is equal to 39.9 hours. Okay, now remember this log here, you would have to convert change of base. So this would be log 0.17 divided by log 0.9576. And that you would be able to do on the calculator or our calculators in test mode. Okay, got a break here, so tune into the last screencast for the rest of the review sheet.